Okay, so what if an AI could think like a master detective? In this explainer, we're going to dive into exactly that. How a really special kind of AI is being trained to hunt down one of the most dangerous digital threats we face today, ransomware.
And to kick things off, just look at this number, 623.3 million. That's how many ransomware attacks happen in just 1 year. Think about that. We're not just talking about a nuisance. This is a full-blown digital epidemic. So, let's make sure we're all on the same page. What is ransomware anyway? Well, the easiest way to think about it is digital extortion. It's nasty software that gets into your system, locks up all your files, and basically holds them hostage until you pay a ransom. Yeah, this is the villain of our story today.
And we really need to understand this isn't just some tech nerd problem. It's a massive, worldwide digital crime wave. These attacks cause incredible damage, financially, operationally, to literally everyone, from you and me to the biggest companies on the planet.
So for years, the way we fought back was, well, kind of basic. It's called signature-based detection. The best way to picture it is a security guard standing at a door, right? And he's got a big book with photos of all the known bad guys. If someone from the book tries to get in, nope, you're not on the list. Simple and effective. Or is it?
And right there, that's the big problem. That security guard is great at catching the criminals he already knows. But what happens when the criminal wears a disguise? Or what if it's a brand new criminal he's never seen before? Modern malware is super sneaky. It constantly changes its appearance to get past that guard. And that is the nightmare scenario that keeps security experts awake at night.
Okay, so to fight these criminals in disguise, we need a new kind of cop on the beat. Enter the hero of our story, a digital detective. And this detective, well, they don't need a photo album to catch the bad guys.
This is the game changer, right here. It's a total shift in strategy. Instead of asking, hey, do I recognize your face, our detective is asking, wait a minute, what are you doing? It's all about analyzing behavior, spotting suspicious actions and patterns, not just looking for a familiar face. That's how you catch the new villain in town.
All right, so let's open up the dossier on our new detective. The official name? A decision tree algorithm. It learns its craft through something called supervised machine learning. All that means is we show it tons and tons of examples. This is what a bad guy does. This is what a good guy does, until it can tell the difference on its own. Its whole mission is to watch what's happening in a computer's memory and spot the telltale signs of a crime in progress.
Decision tree algorithm. Yeah, I know, it sounds super technical, but honestly, the way it thinks is something we can all understand. It's basically like playing a really, really fast and logical game.
I mean, think about it. How do you actually get a computer program to make a complex judgment call like, is this a threat or not? The stakes are huge. It's not just about math. It's about delivering a final verdict, guilty or innocent.
And the answer? It's pretty cool. It's a lot like a game of 20 questions. The AI just asks a bunch of simple yes or no questions about what it's seeing. Each answer, yes or no, sends it down a different path, and with every question, it gets one step closer to the truth.
And this is what that game of 20 questions actually looks like inside the computer. It all starts at the top, at what's called the root node. Think of that as question number 1. It might ask something simple like, is this program renaming a ton of files really, really fast? If the answer is yes, it goes down one branch. If it's no, it goes down another. It keeps asking these questions at each decision node until, wham, it hits the bottom. That's the leaf node, and that's the final verdict. Ransomware or just a harmless program.
So this whole thing basically breaks down into 2 big steps. First up is the training phase. This is like our detective spending months in the archives, studying thousands of old case files, learning the signature moves of the criminals, and the normal routines of innocent bystanders. Then comes the testing phase. We unleash it on brand new cases it's never seen before to see if all that homework paid off. Now, obviously, a detective is only as good as the evidence they study, right? You can't learn to be a great cop by reading comic books. And in this research, the AI was trained on the real deal, a huge collection of evidence from actual, real-world digital crime scenes. The evidence came from a collection called the Obfuscated Malmem 2022 dataset. It's a pretty famous and notoriously tough dataset in the cybersecurity world. It's packed with memory dumps from real messy malware attacks, which makes it the perfect boot camp for our AI detective.
And you can see here, the AI didn't just study one kind of criminal. It learned from a bunch of different notorious ransomware families. You might have heard of some of these, like Conti and Maze. This variety is super important. It's like teaching a detective to spot not just burglars, but pickpockets and con artists too. You want them to recognize all the different styles.
But before our detective can even look at the evidence, you have to clean it up. This is called pre-processing. You know, real-world data is messy, so you have to do things like turn text labels like "can't" into numbers the computer can understand. And you have to make sure all the data is on the same scale, so one piece of evidence doesn't look more important than another just because it's a bigger number. It's basically like organizing all the messy case files into neat, easy-to-read folders.
Okay, so the AI went to detective school. It studied thousands of cases. It learned all the criminal patterns. The big question is, how did it do on its final exam? How did it perform when we put it to the test? Well, the results were pretty incredible.
And here it is, the big reveal, 99.97%. That's the accuracy our decision tree detective achieved. It was right 99.97% of the time when deciding if a program was dangerous ransomware or totally safe. I mean, that is just a stunning level of precision.
And hey, don't just take my word for it. The researchers who ran the whole experiment said it themselves, right in their paper. The decision tree classifier, our detective, consistently outperformed all the other AIs they threw at the problem.
And here's the data to back that up. This table lines up our decision tree against a few other AI models. And you can see across the board on accuracy, precision, and recall, which is its ability to find all the bad guys, it's at the top. Now, you might look at those numbers and think, hey, they're all pretty close. But in the world of cybersecurity, that tiny fraction of a percent is everything. It's the difference between protecting thousands of computers or letting an attack slip through. So yeah, the others were good, but our detective was the best of the best.
So, let's zoom out. What's the big takeaway here? Why does this one cool experiment matter for the future of how we all stay safe online?
It matters because this isn't just about one algorithm. It's a blueprint. It proves that by focusing on behavior, we can finally start winning the endless cat-and-mouse game against cybercriminals. We can build security that's proactive, that anticipates threats, instead of just reacting after the damage is already done. We can actually stop these attacks before they happen.
And that leaves us with a really exciting question to think about. This whole project was focused on ransomware, but just imagine, what if we could use this same hyper-accurate, behavior-based detective work on all the other digital garbage out there? Phishing scams, spyware, you name it. The potential here to build a fundamentally smarter and safer digital world for all of us, it's just huge.